All right, today we're going to start with talking about Chapter 12, Access Management. The objectives of Chapter 12, we're going to look at defining access management and list the access control models. We'll describe how to manage access through account management, the best practices, and how to implement access controls, and explain the different types of identity and access services. So when you look at this, access controls are granting or denying approval to use specific resources. We've got two types of access controls. We have physical access controls, which are going to consist of fencing, hardware door locks, band traps. It's how we're going to limit access to our devices, limit the attacker's access to the computers or whatever type of devices that we're limited access to. Technical access control consists of technology restrictions. It's going to limit users on computers from accessing the data. So these are the standard access control models that we use to help enforce access control. Now we get into access control, we have to talk about the terminology. The identification, this is presenting your credentials. So for example, your username. This is saying who I am. Authentication is checking the credentials. This is how you prove it. This may be something using a password to prove that you are the username. Authorization is granting permission to take action. And then accounting, that is a record that's preserved of who accessed the network, what resources they accessed, and when they disconnected. So it's a record of your activity while you're in a network. So we just went over the descriptions of these. So let's look at the computer process. So authentication is the enter user's username. The authentication is where the user provides a password. So they're saying this is who I am and this is how I prove it. Authorization is the user is authorized to log in. Access is the user is allowed to access only specific data. And accounting is that information is going to be recorded into a log file. A couple other terminology we need to learn for access controls is object, subject, and operation. All right, object is a specific resource, such as a file or hardware device. Subject is going to be the user or process that's going to be functioning on behalf of the user. The example here is a computer user. An operation is going to be the action taken by the subject over the object. So we see here in this chart, we've got the different roles. The privacy owner is the manager who oversees data privacy compliance and manages data risk. We see his duties and an example. Example is he decides that users can have permission to access the salary spreadsheet, Excel sheet. Custodian or steward is the individual whose day-to-day actions have been assigned by the owner. And what they do is they periodically review security settings and maintain records of access by end users. The owner is the person responsible for the information. They determine the level of security needed for the data and delegate security duties as required. And the end user is the user that accesses information in the course of their routine job responsibilities. So they will go through and they will follow the organization's security policy, the security guideline. They do not try to circumvent security. So an example here is they open the salary document. Okay, so we just went through this chart here, this diagram. Okay, so we get into access controls. We have the access control model is the standards that provide a predefined framework for hardware or software developers. And we could use the appropriate model to configure the necessary level of control. We got 5 major access control models. You have discretionary, mandatory, role-based, rule-based, and attribute-based. We'll go through each one of these. Discretionary access controls, this is the least restricted model. Now in here, every object is going to have an owner. The owner is going to have total control over their objects. The owners can give permissions to subjects, other subjects, over their objects. This is what you see in the Windows and Unix operating systems. And that does have two big weaknesses here. It poses a risk since it relies on the decisions by the end user to set the proper level of security. And also, as subjects permissions will be inherited by any other programs in the subjects the subject executes. Because you've seen this in Windows, hopefully, in this Windows discretionary access control window, we can set the security. So we have our group, our usernames that are set, and in here we've added the permissions for them. So we've set to allow full control to modify documents, read and execute files. And these you can set these to deny as well. Mandatory access control, this is the most restrictive access control. And this, the user has no freedom to set any kind of controls or distribute access to other subjects. This is something you usually find in military. When in here, you got two different labels or elements. You have a label and a levels. Now with this, the labels, it's every entity is an object, and it's going to be assigned a classification label that represents the relative importance of the object. The subjects are going to be assigned a clearance level, a privilege level with this, or label. Now levels on here is a hierarchy based on the labels that are used. So example, we'll see that top secret has a higher level security than secret. It's going to have a higher level than confidential. And in that, the subject still has to have that clearance level. They have to have the secret clearance level to access items that are on the secret level. So the levels are going to indicate the level of privilege. So it matches the object level with the subject levels, labels, and allows them in or denies them. With mandatory access control, you've determined the file may be open, the object and the subject labels are compared. The subject must have an equal or greater level than the object to be granted access. So if you have something lower, you will not be granted access. And you see two major implications of a MAC, the mandatory access control, in here as well. All right, Windows is also going to use a MAC implementation. It's called mandatory integrity control. In this, here it has a security identifier that's going to be issued to the user group or session. And every time the user logs in, the CID is going to be retrieved from the database for that user. It's going to be used to identify the user with any interactions with Windows. It's going to link that to an integrity level, the SID to an integrity level. And you're just going to see this in the user access control. It's a window feature that controls users' access to resources, as we see in this image here. All right, role-based access controls. This is also called non-discretionary access controls. What this does, it allows permissions. Access permissions are going to be based on the user's job functions. So what we have here is we have permissions are going to be assigned to a role in an organization, and then the users are assigned to that role. All right, so if you have a job title in this that belongs to a certain group that's been created, and it has those permissions. So this is one of the easier ones to manage. When you're managing individual users and people are coming in and leaving, it's easy to leave off a security permission, leave off one of the permissions, or maybe grant too much permissions. With a role-based access control, the permissions are going to be granted to a group. Okay, and then the users will be assigned to that group. So if you had to add a user, once you assign them to that group, those permissions are applied. Once you remove them from that group, the permissions are removed from that user, that subject. All right, role-based access controls. This does is it dynamically assigns roles to subjects based on a set of rules defined by a custodian. So every resource object contains access properties based on these rules. When the user attempts access, the system is going to check the object rules to determine access permissions. And that's something you usually see when it's often going to be used for managing user access to one or more systems. Attribute-based access controls. It's more flexible policies than rule-based. It lets you combine attributes. And this allows you to take advantage of the attributes over the object, subjects, or environment. These can also be formatted using a if-then-else structure. So you can say, if this happens, then do this. Else, do something else. So, for example, I can say, if the username and password match, then allow access. If they don't match, I can say deny access, else deny. All right, so this is an attribute-based access control chart. In here is going to show the different types of access controls, explanations, and descriptions of those that we just went over. All right, so we're managing access through account management. And it's very important we have properly configured accounts. This is going to be our first step in providing strong security. That's something that's not only going to be user accounts, limited user accounts, we also make sure the service accounts and privileged accounts are properly configured as well. Now, account management, this is also including account setup as well as account auditing. So when we're initially setting up an account, some things we need to take into consideration include employee accounts, maybe creating location-based policies, establishing a standard naming convention, creating time of day restrictions, and enforcing least privilege. So employee accounts, when we're creating employees, when employees are coming into the organization, coming into the company, or if we've got a new hire, some onboarding steps include scheduling, job duties, socialization, workspace, and training. We may have to do things such as provision of the new computer, set up the computer, create email mailboxes and Active Directory users, add the user to groups, create home folders, review security settings. So these are things that we go through when an employee is coming on. The reason we do this is because our employee accounts are often the source of entry points by our attackers. Getting this information, and an improperly configured account could give the attacker easier access. It could give them more access to information that they're not required to have or allowed to have, the employee. Employee offboarding, this is when the employee leaves an organization. The steps we have in here include backing up all employee files from the local computer and server, archiving email, maybe forward an email to a manager or coworker, hide the name from the email address book. Orphan accounts or user accounts that remain active after an employee's left. And dormant accounts are accounts that have not been accessed for a period. Now, many organizations will disable an account for a minimum of 30 days and then purge disabled accounts once or twice a year. Location-based policies, geofencing rules. Geofencing is going to rely upon a location-based policy. What this does is creates a geographical boundaries where mobile or devices can or cannot be used. These are often going to be prescribed by generating IP location data file. You see that the text file contains comma separated fields in this format. It's also a good idea to have standard naming conventions. These are rules that have been established for creating account names. We have them here. You'll see that the options for these, typically you're going to have it set up as the first initial followed by the last name. It may be a first name with a punctuation mark followed by the last name. Typically, a lot of times you'll see it as an underscore. Maybe a last name followed by the department code. Now, with this, when you're setting up the standard naming conventions, you need to take into consideration that some people may have the first and last name that's going to be the same. So you would have to set up a standard policy for establishing the naming conventions in case you do run into a situation where the two names are the same. You also have a time of day restrictions that can be set, which just limit the time of the day that a user can log into their account. As we see here that they have the time of day block, so they start blocking at 18 hours and 30 minutes, and it ends blocking at 24 hours. So we see here that these times the user cannot log into their account. The principal least privilege, that means that you only give access to what the person needs to do their job and nothing more. What this does, it helps reduce the attack surface by eliminating unnecessary privileges that can provide an avenue for the attacker. So what it does is it really limits the scope of an attack to that person's job functions. This is something that should be applied to both user accounts and processes running on the system. So you only give them the permissions to do what they need and nothing more. Account auditing, this is where you periodically maintain, periodically go in and look at their accounts, maybe something for recertification. So you go in, you periodically reevaluate the user's account, access control, membership role, make sure that everything is still correct. Permission audit and review is intended to examine the permissions that a user has been given and determine if they're still necessary. You can also do the uses auditing review, where you go in and look at the users' applications they've used, how they use them, how frequently they use them. Now we're going to look at some best practices for access control. This is something that can help secure your system of data. Some examples here are separations of duties, job rotations, mandatory vacations, clean desk policies. Separation of duties, this has helped to cut down on fraud. Fraud can result from a single user being trusted with complete control over a process. So it may be separation of duties requires 2 or more people to handle any functions that are dealing with money. And what it does is protecting the company because it makes sure that the system's not vulnerable to the actions of a single person. Now we look at how this relates to computer access. Okay, so here it requires that a fraudulent application or process that could be potentially result in breach of security. The process should be divided between 2 or more individuals. Job rotations helps with burnout, first of all. And what this is, it's where you periodically move between different job responsibilities. So it's reducing the employee burnout. They're not doing the same thing day in, day out. Some other advantages of this is it limits the amount of time the individual may have in a position to manipulate the security settings. And also can help by expose potential avenues for fraud. New employees coming into that job may have a different perspective and may be able to see things differently than you've looked at. May be able to find a new vulnerability that can be stopped. Mandatory vacations. This also limits fraud because the perpetrators must be present to hide fraudulent activities. This is also a good time to do the audit of the employee's activities for sensitive positions while they're on their mandatory vacations. Clean desk policy is designed to ensure that all confidential or sensitive materials are removed from the user's workspace and secured when the items are not in use. This will be something that's either in paper or electronic form. We'll see an example here. Some sample statements that may be found in a clean desk policy include that the workstation must be locked when the user leaves. Maybe turn it off at the end of the day. Cannot have confidential or sensitive information laying on your desk. It must be removed. It must keep your locks, your file cabinets locked, your laptop locked up as well. Those are some examples you'll find in policies. This clean desk policy should be written into your security policy. It maybe includes, one of the things I've seen a lot include is don't write your password down on sticky notes. Don't leave that, which goes into the confidential information. You don't write down your password and put it on your monitor or anyone's phone number. Sensitive information should not be written down and left in plain view. You can also use technologies that can be used to implement access control, include access control list and group-based access control. All right, an access control list, that's a set of permissions going to be attached to an object. It says what subjects may access the object, what operations they can perform. So when a subject goes in and he tries to access an object or perform an operation, the system's going to check the ACL for the approved entry. They're usually viewed in relation to the operating system files. They provide file securities for protecting files managed by the OS. There's something that's also now being used in SQL relational database systems to provide database security as well. All right, so when you have entries in ACL tables, it's called the access control entry. Windows uses the A structure. We have a security identifier for the group or user account or the login session. The access is going to mask a specific access rights controlled by the ACE. Flag is going to indicate the type of ACE. Sets of flags are set to determine whether objects can inherit permissions. Group-based access control, that's going to permit the configuration of multiple computers by setting a single policy for enforcement. So, for example, in this Microsoft Windows, it provides a centralized management and configuration of computers and remote users using AD, Active Directory. This is going to be stored in the group policy objects. Now, you also have a local policy, local group policy. You'll have fewer options than group policy. It's going to be set up to configure settings for systems not part of the Active Directory. All right, so we do have some different types of services can be used to provide identity services and access services. We see here on the screen some different types. Radius is remote authentication dialing user service. It was developed in 1992. It did become the industry standard. It was really designed for remote dialing access to corporate networks. It does use a client as well, the Radius client. And in there, it's going to typically going to be a device such as a wireless access point. It's responsible for sending user credentials and connections parameters to the Radius servers. And those profiles are going to be stored on a central database that all the remote servers can share. Now, the advantages of using a central service is that it increases the security. It's got one single administrative network point. Okay, so it increases the security there. Which also makes it easier to track usage for billing and keeping network status as well. We see on the screen here the laptop sends its username and password. That is sent to the Radius server. The authentication request compared with the user in the database. The acknowledgement and authentication are sent to the access point and the approval to the laptop. And the records in the accounting database are located here in step 5. And should be able to access. All right, authentication systems developed by MIT uses encryption and authentications for security. This does kind of works like using a driver's license to cash a check. The ticket characteristics include that it's difficult to copy, it contains information linking it to the user, it lists restrictions, and it does expire at a future date. Terminal Access Control System Plus. This is an authentication service. It's going to be similar to the Radius. It's commonly going to be used on Unix devices. And what this does, it communicates by forwarding user authentication information to a centralized server. You see the current version there. All right, here we see some features and the comparison between the TAC8, CS Plus, and the Radius. The lightweight directory access protocol. This is a directory service. The directory service is a database stored on a network. It contains information about the user and the network devices. Keeps track of network resources and users' privileges for those resources. And it's going to grant or deny access based on that information. The LDAP was designed to run over TCP/IP. Traffic is transmitted in clear text. Now you can use the SSL or TLS to make it secure, which then changes it to secure LDAP or LDAP over SSL. Weaknesses of LDAP is it can be subject to LDAP injection attacks, which are going to be similar to SQL injections, and that occurs when the user input is not properly filtered. All right, the Security Assertion Markup Language, SAML. It's an extensible markup language. A standard that allows secure web domains to exchange user authentication and authorization data. Now, it allows user login credentials to be stored with a single identity provider instead of being stored on each web service provider's server. This is something that's going to be used for online e-commerce from business to business or business to consumer transactions. All right, so we see an example here of an SAML transaction. So we see the user attempts to reach the service provider. So it goes to the service provider generates this SAML request, and a redirect URL is sent. And from here, the user is going to the redirect URL. Over here in the identity provider decodes that request and authenticates the user. The identity provider is going to create the SAML response is going to be created, and it's going to be signed. It's going to be sent back to the user. User browser is going to forward that request to the service provider, and from there the SAM request is going to be verified and the user is logged into the service provider. The authentication framework protocols. The framework for transporting authentication protocols is known as the Extensible Authentication Protocol. This was created as a more secure alternative to the Challenge Handshake Authentication Protocol, the Microsoft version of the Challenge Handshake Authentication Protocol, and also the Password Authentication Protocol. Now, what the EAP does, it defines the format of the messages. It uses 4 types of packets. It's going to use a request, response, success, and failure. So that ends chapter 12. In chapter 12, we went over access control, the 5 major access control models, configuring accounts with proper permission, and why that is the first step in providing strong security. What to do when we create an account, what to do when a user leaves the account, leaves the organization. We looked at the best practices for implementing access control. We looked at some different types of services that we provide identity access services. We looked at some different types of directory services and how to implement access control methods.